Greetings and welcome to the series of lectures on exponential and logarithmic functions. In this lecture, we'll discuss how to rewrite logarithms as exponents. So the idea of this lecture is that we can take logarithms and rewrite them to where they look like exponents. So the expression y equals log base b x is read, y is the logarithm of base b of x. But we don't generally say logarithm all the time, we just say log. Okay? It's equivalent to the expression x equals b to the y, where b is greater than 0 and b does not equal 1. Okay? B to the 1 is just boring, so we just leave that out. Y is the number we raise to b in order to get, we raise b to in order to get x. So when you're looking at y equals log base bx and you want to translate that over to the exponent, b is the base. That's the base we're raising to a power. Y is the power, and x is the answer. That's how we're going to talk about rewriting logarithms into exponential. All right, so the logarithmic form is y equals log base b of x. All right, so let's take a peek at some of these. Right? Exponential form, 8 equals 2 cubed. The log form, the logarithmic form, is log base 2, 8 equals 3. 25 equals 5 squared. Logarithmic form, log base 5, 25 equals 2. 0.1, well, that's 10 to the negative 1, so it's log 10, base 10, 0.1 equals negative 1. Now, we also, and we'll talk about this in another lecture, but we can also leave off the 10, because 10 is our number system, therefore we can leave that off. It's an implied base, so we could say just log of 0.1 is negative 1. 1/8, well, that's 2 to the negative 3. In other words, log base 2 of 1/8 equals negative 3. And then, just a generic one, r equals z to the s. That's going to be log base z of r equals s. All right, so let's try an example. Let's solve for x. Log base 3x of x equals negative 2. So I'm going to rewrite this in exponential form, starting with the base 3. 3. In the logarithmic form, what it equals is the power in the exponential form. So negative 2 is the power. And then, therefore, it equals the answer of x. Now I know how to take the exponent, needs to be positive, so I'm going to bring that down to the denominator, x equals, and therefore I'm just going to do this math here. X equals 1/9. All right, so let's try another example. Let's solve for x of log base x, oops, sorry about that, log base x of 4 equals 3. First thing I want to do is rewrite it in exponential form. Base is x. Power is 3. The answer is 4. Since I'm solving for x, I'm going to take the cube root of both sides. Therefore, x equals the cube root of 4. That's it. All right, let's try another problem. Log base 8 of 4 equals x. I'm going to rewrite it in exponential form. Base is 8, power is x, equals 4. Now there's a couple of ways of solving for this, but what I want to do is if I can get if I can change this base to be the same base on each of the sides, then all I need to do is compare the exponents. 8 can be rewritten as 2 cubed all to the x power. 4 can be written as 2 squared. Now if you remember your exponential rules, I have a power raised to a power, so I multiply those together. I have 2 to the 3x equals 2 squared. Since the bases are the same, the powers must also equal. So now my problem becomes 3x equals 2. And now I'm going to solve for x. Divide by 3, divide by 3. X equals 2/3. But let's check this just to be sure. Okay. Let's plug that back in. 8 to the 2/3, does that equal 4? There's a couple ways that we can do this. We could say 8 raised to the second and then take the cube root. That's one way of doing it. The other is take the cube root of 8 and then square it. Okay. I think I'm going to do that because I can rewrite this as 8 squared to the 1/3. Does that equal 4? Or the other way I can write it as 8 to the 1/3 squared. Does that equal 4? Here, if I do the first version, it's going to be 64. The cube root of 64 is 4, and 4 indeed equals 4. Or I could take the cube root of 8. Well, the cube root of 8 is 2, and 2 squared is 4, and 4 does equal 4. So either way, it does check out, but when you have a fraction as an exponent, you can break it up. Either do the squaring or the whatever power first and then take the root, or you can take the root and then do the power. In this instance, they were both kind of equally the same. I did like taking the cube root of 8 a little bit better because then I was working with smaller numbers. But in essence, it's up to you how you verify your answer. When you're asked to graph a logarithmic function, you're actually going to use the exponential form. And since we covered that in the previous lecture, I'm not going to go into in depth here. But we can do y equals log base 2 of x. Y equals log base 2 of x is going to be equivalent to base 2, power y, answer x. So x equals 2 to the y. I'm not too sure how to graph 2 to the y, so I'm just going to graph the inverse, and then I know the inverse is mirrored with the actual equation along the xy line. So either you can just plug in some values for y and get x's, or you could graph the inverse and then go back to the original equation. It's up to you. We discussed this in a previous lecture, so I'm not going to go into details. But the inverse is in blue. That's where y equals 2x. And along the xy line, my original equation, which is not x equals y2, it's actually y equals the log base 2 of x, right? That's just a different form of the same equation. But our original equation was y equals log 2 of x. All right, we have two special identities when it comes to logarithms. If b, lost my pen. If b is a positive real number, and it's other than 1, meaning that b is greater than 0 but not 1, then each of the following consequences are the definition of a logarithm. 1, b to the power of log base b x will equal x. And 2, log base b of b of x, b to the power of x will equal x. In other words, if you want to think of it, this front portion cancels each other out. Raising a power to a log, raising to a power, and doing the log of the same base will cancel each other out. Taking the log of a base and then doing a base to a power, that log base b of a base b will kind of cancel out. So you're left with x equals x and x equals x. At least that's kind of how you can think about it. The proof is a little different, though. I'm going to take the first one. b log base b of x equals x. Well, I'm going to take this exponent, I'm just going to say it equals y, just so it's written a little easier. So b to the y equals x. Now remember, y equals log base b x. And log base b x, when I rewrite it, right, the base is b, that's this log of b, the answer is x, and the power equals the power. I've rewritten it in logarithmic form. But remember what the original y equals? Log b of x. Well, this y equals log b of x, so log b of x equals log b of x. Okay. So we kind of went in a circle. If they both equal one another, I can divide them out of each side, and then I'm only left with x. Likewise, if log base b of b of x equals x, then I can take this and rewrite it base, exponent, answer, base, exponent, answer. So b of x equals b of x. Okay again, right? They both equal one another. So it's a little difficult to see, but since they are true, we can utilize this fact to kind of simplify our problem. Here's what I mean. I'm just going to show you all of these at once. Log 2 of 8. Well, that's the same thing as saying log base 2 of 2 cubed. Well, log 2 of 2 cancels out, and 3 will equal 3. Let's try another one. Log base 10 of 10,000. Well, I can rewrite 10,000 as 10 to the 4th. Well, this log base 10 will cancel out, leaving the answer is 4. 4 equals 4. I don't know what it equals. Here's log base b of b to the 1st, and therefore the answer is 1. Log base b of 1. Well, how can I rewrite this 1? As b to the 0. Since log base b kind of cancels out, my answer is 0. Log base 4 of log base 5 of 5. Well, log base 5 of 5 is 1. So I know log base 4 of 1 is 0. Okay, because I go right back to problem D. If it equals 0, then it's got to be the power of 0. Okay, so just work on those, finagle them out. I think you'll be okay with those. All right, so back in another example, another lecture, we talked about the measure of an earthquake. And if an earthquake has a shock wave of t times greater than the smallest shock wave that's measurable on a seismograph, then the magnitude is given by the equation. The magnitude equals log base 10 of the shock wave measure. Okay. So using that, I want to know if our magnitude is 5, what can we say about the shock wave? Plugging it into the equation, I get m equals log base 10 of t. That's our equation. Plug in 5. 5 equals log base 10 of t. Rewrite it exponentially. Sorry about that. 10 is the base, 5 is the power, t is the answer. So 10 to the 5th equals t, therefore t equals 100,000. So in other words, the shock wave for an M5 is 100,000 times greater than the smallest measurable shock wave. Now this is different. It's bigger than the smallest measurable shock wave. That's different than the energy the earthquake puts out. That's another equation. This is just how big it is, not the energy that's released. So here's how it goes. M0 means that it's 1. It's 10 to the 0th power. That's what we're measuring against. A magnitude 1 is 10 times greater than the smallest one. In other words, 10 to the 1st. A magnitude 2 is 10 squared, so it's 100 times greater than the smallest one measurable. A magnitude 3, when we multiply the last one by 10 and we get 10 cubed, that means it's 1,000 times larger than the smallest measurable shock wave. And we continue this pattern. So an M9, a magnitude 9 earthquake, is going to be 1 with 9 zeros. So it's going to be 1 trillion, right? Wait, 9 zeros. So that's hundreds, thousands, millions. So that's 100 million times, no, 1 billion. What am I thinking? 9 zeros is 1 billion. 1 billion times larger than the smallest recorded shock wave. That's why when we measure earthquakes, when you see the magnitude on the news or whatever, that they grow exponentially. They get larger and larger and larger very quickly. You usually don't feel an M1 or an M2 or maybe even a very small M3. You should start feeling them M4, M5 around your neighborhood. You certainly start feeling those. And magnitude 7s you can feel 100 miles away. They just grow that quickly. So that's all I wanted to do for this lecture. Until next time, be seeing you.